All right. There we go. Levels. Check in, check in, check. And we're live. Okay, cool. Hi. It has been a while. A hot minute. Dang. Yeah. I've been out for a few weeks now, I guess. Various issues going on, but I'm back and healthy and I'm whole again. So everything's good. Welcome to the stream. It's your first time tuning in. I am Agent Ultra. I am here to program and chill and hang out with you. I write code mostly in Haskell on this stream. And we build random whatever stuff. Last bunch of whiles, we've been working on implementing and learning about wave function collapse. So, I haven't touched this code in a hot minute. I haven't really looked at it in quite a while. But I did kind of review my my notes as I've been going along, trying to refresh my brain about it. So if you don't know what wave function collapse is, it is basically a cool little algorithm for generating textures and images and stuff like that from a small sample size and a bunch of, which the small sample kind of sets up a bunch of rules for how to place tiles next to each other and creates kind of these bigger pictures out of the smaller one. Using the input picture is kind of like a rule set. So it's a class of algorithm that I believe belongs in the the constraint propagation solver sort of family of algorithms. And so that's what we're going to work on today. We're going to get back, we're going to review. This will be a good test. One of the, for Haskell. So one of those things I really believed about Haskell early on was that this is a programming language where you can take some time away from what the code you wrote, you come back to it, you kind of figure out what's going on pretty quickly. So we're gonna test that theory out tonight, of course, and see where we're at with things and where we need to go. I believe we were pretty close. We're getting fairly close. Just make sure my camera's set up here. There we go. But I believe we're getting pretty close here. So we're getting near the end of this. So I don't know how accurate this to-do list is. So let's look at some actual code. Adjust some stuff here. There we go. Okay. Let's go to source. We'll go to algorithm. I gotta get rid of that lib module. I don't know if that's still in there. Okay, cool. So let's bring this out. There's our propagate step. Okay, so this is the general overall pattern we gotta go for. While the pattern removal stack is not empty, this is kind of in the meat of the propagation sort of stuff. We gotta pop the top of the stack off. We get the pattern to remove at a certain cell index. And then we iterate for each direction. We modify the cell at cell index plus direction, so the neighbor. And eliminate the pattern from the set of possible patterns based on the adjacency rules. Let's see, for each direction, get the set of enabled cells to the one we're looking at, based on the adjacency rules, and push those as removals to the pattern removal stack. Then we gotta update the update the cell's entropy and entropy cache, and then insert the cell into the heap list. Okay. I think that still makes some amount of sense. Although this inner loop of for each direction, that one I'm not so sure about. I think we don't even need to nested list there. I think we just need to do the eliminations. Okay, and eliminate. Not implemented yet. We got to do that. So for eliminate, we want to remove patterns from the set of possible patterns for this pattern index based on the adjacency rules. and get the set of not enabled patterns for cells in each direction. Add those patterns to the pattern removal stack. Right. Okay. I think it's coming back to me, folks. So modify cell at, okay, so this takes, I guess, an index into the grid. A function that you can pass in, a high-level function here for manipulating the cell, and then we just update the cell at that location in the state. Pretty straightforward. So far, so good. Okay, choosing cell, getting a cell, adding a cell, entropy cell, okay. Some helpers. Okay. Going up a little bit. We've collapsed the wave. At a high level, while there's remaining cells to collapse, we propagate it. Propagating the collapse, we choose a cell. We collapse the cell at that index, and then we propagate, and we're done. Yeah, that seems a little bit okay. Possible, maybe. And maybe propagates what's going to loop around on this stuff. Right, and we did look at this already, so we pop the removal stack. If there's nothing, then we're done. Otherwise, we get the remove pattern, we eliminate it, which we have to implement. Okay, so I guess that's probably where we're at right now. Yeah, and I think we should probably go back and look at that other stuff once we implement eliminate. So let's focus on eliminate for now. Get this nasty undefined out of here. Okay, so we want to eliminate a pattern from a cell. We want to remove that pattern from the cell. Let's remind ourselves of what the remove pattern definition is. Right, it's got the cell pattern index to remove. So we refer to all of the patterns that are in the wave by their index into like I guess an array of, I think it's an array of patterns. So we refer to it by its index, and then the propagate cell. So that's the cell index to remove the pattern from. Okay. That means we need to get the grid out of the state. Possibly, or we have a helper for this. Get cell at. Right, we have the get cell at function, so we could get the cell at that location. And, oh, we have modify cell at. That's probably what we really want. Right, and then we have the remove pattern. Cell index. And our function. Sorry, propagate cell X. Remove pattern. There we go. So once we do that, then we have to get the set of not enabled patterns. for the cells in each direction. So by eliminating the value here, we've changed, based on the adjacency rules, we've changed what potential values we can pick for our neighbors. And some of them won't make sense anymore, and those are the ones we want to pick for elimination. So I'm going to get those out and then put them on the removal stack. And so I'll call it, say, neighbor removals. All right, that's going to have to reach into the state, so we'll bind that to get neighbor removals. We're going to give it the pattern index. All right, so the pattern we just removed. So then that should figure out each one. We need to do it for each direction, so why don't we just do that here? So that's going to be a state function. I don't think we're going to be binding that this way. Nope, we're going to be doing a sort of like that. Directions. Like that. So for each of the directions, get the neighbor removals with the propagate pattern index that we just eliminated, and then we're going to just push those onto the stack. Neighbor removals. Alright, that should cover elimination. Because then the job of propagate is to continue to call this until the stack is empty, when there's nothing left to propagate. So this might not make a whole lot of sense here, unless we concatenate the results back. Just sort of a type there of forum. Okay, yeah, so in its return type here, we see that it's a monadic action it returns, so that'll be our state wave state. But this T of B's is a traversable, so like potentially a list of our B values that were returned by our action here. Our inner action. Yeah. That should be good. So our B's and gate neighbor removals, the type of this, might actually be a list, the return type here. So we will need to also concatenate this, or flatten this list. I think we'll just be join. A list of A's down to A. Fine. There might be a nicer way of writing that. There you go. Okay. Then we just gotta get rid of all these red squigglies. Propagate cell pattern X is probably what we meant. Yeah. Okay, so then we got to implement get neighbor removals. Right, we get the neighbor removals. We actually want a function. Oh, I want you to tell me what the type is, GHC, or what should be. Push removals. It's going to be a list of remove patterns. Do state, wave state, unit, pushing the removals. There we go. That's the type error I wanted over here. This is going to be int direction, which is really going to be pattern index. Call pattern X, pattern index, index, direction, state, wave state, unit. Yeah. Oh, and it's got to return a list of remove pattern. Of course. Bring this over a little to the left. Bang, bang, bang. Okay. Oh, Not quite, not quite. T of A. That's the list of directions. Oh, I see. The A goes in the first position of our function here. Which is fine, because if we do pattern index here, and it's a function of direction to state. Hmm. Pretty sure I had that right, but maybe I got it wrong. Okay, it wants wave state identity. Yeah. Direction. Now. Just copy this. Oh, there's some weird formatting in that. And grab that over there. Oh, that's why. Right. Okay, maybe the problem was join, forcing things here. Ah, it is. Yes. Okay. Get rid of that, and we'll just do the join here. Flatten that down. And then we just have the hole here. Okay, so this function for modify cell at, we just have a function cell to cell, which of course is where we want to remove this cell index. And that's going to be cell to cell. Right, and here, are we using lenses in this? Please tell me we're using lenses. Otherwise, we'll just have to use record updates index. Doesn't look like we are. That's okay. So we want cell such that have to remember the cell structure. Cell possibilities. So the in this array at this pattern index, we're going to set it to false. That's going to need a data.arrays, update syntax for that. Which, one of these days, I'm going to load this entire module in my mind. I'll never have to look this up again. So looking up the value, we can just use, yeah, // All right, so we're going, that's the array on the left. And our tuple will be we need the we need to pass in an argument to remove cell index, propagate. Cell pattern X. So we can do pattern X false. Okay, and it's going to go over a little bit. Okay. All right, let's get our code builder going here. We'll use the test runner. We use fast. File watch. Make sure that all compiles. Looks like we're good in that department. So long as we can actually implement now get neighbor removals and push removals. Oh. Nate, oh, whatever your name is, I don't appreciate this. You're banned. All right. So get neighbor removals. This is going to be a very... This is going to be the tricky one. So for... I'm going to rename this to pattern index. Not just any old int. Right. Oh, it needs more information. It needs the base index from that direction. So we need the propagate cell X as well. All right, so that's going to be an int here. Pattern index there. Okay. This is going to be the cell index. Base cell index, I guess you could call it. The pattern index direction, and that's that. All right. So now, from the base cell index and the direction, we need to figure out cell. What else are we also going to need to figure out the removals? We're going to need the Hopefully this is in the state. We're going to need the adjacency map. The adjacency map. We get the rules. And then that means we can return the list of removal pattern. Alright, cool. So getting that is no problem. Get cell at. So get cell at. We need like a from direction function. Which will use the base cell index and direction to figure it out. Coordinates to get the cell. Once we have the cell, then we can look at the list of possibilities. Filtering that list of possibilities based on the adjacency rules. For the pattern index we just removed. So let's look at the adjacency rules. Adjacency key. And this is a map of booleans, whether it's allowed or not. Okay. So in this case, if I recall correctly here, this maybe is not the most descriptive way of encoding this, but pattern B is like our target pattern. And that's the one we target A overlaps and would be allowed, which would be allowed, given what this bool says. So pattern, what I'm saying is pattern B here is going to be the pattern X passed into the eliminate function. The pattern index passed in there. And pattern A will be the ones we're iterating over in the possibilities list. So for each pattern A with our pattern B, we get the boolean. If it is not allowed, then we should turn false. However, it's not that it's not allowed, it's that it's no longer there. That's not going to quite work the way I expect it to. No. What we need to eliminate is any pattern. Yes. I think we need to eliminate any of the pattern removals we need to generate are based on this adjacency key. So wherever in this pattern A, pattern B, and direction. So we might not even actually need to get the cell itself. Oh no, we do it for the possibility. Anyways. If it is enabled by the adjacency rules, so the value is true, then we need to turn that to false. We need to schedule that one for removal, the pattern A. Because it's no longer, because we're eliminating pattern B from the adjacent cell in the opposite of the given direction, then it would mean that we can no longer place a valid pattern A as a potential candidate here. So that was what we want to do. So So we need the cell to get the possibilities to fill in for pattern A's. The adjacency map. Rules. And I do have a function for that. Oh no, let's get adjacency rules. Wave state, we gotta check if the wave state has it. Right, ring cell, adjacency rules, yeah. Wave state, adjacency rules. Give that one. Okay. God, I just went camping this weekend with my kids, which was super fun. And I was very diligent about putting on bug spray around my ankles and stuff as it got dark, around my arms. Still got bites in really annoying places. Oh, so annoying. But not in the places where I sprayed, which is good. It was doing its job. Okay, so what do we want to do? We want to do like a filter here. Alright, over all of the possibilities. I don't know what's put in there yet, but we're going to possibility P in cell possibilities. All right. That's an array. I think we'll work in that syntax. It's foldable. So that'll be... Well, we might have to change it to a soaps, or... Yeah. Or have a little function here to transform it into a list. Ooh, hey, what do we got here? Something I forgot about. Get the list of pattern indices that are not enabled for the input set pattern indices. Given the adjacent rules. Enabled means the possible value in the input cell doesn't match any rule involving the input pattern for the given direction, where the input pattern is the target and the possible value is the source. So you give me, not enabled, you give me a not empty list of pattern indices, a direction, the adjacency rules, and a cell. And I'll give you the list of pattern indices that are, I assume, are not enabled. Right. So this takes the possibilities, which we were just about to do. transforms with the array associations. Filters on the second. So only the enabled ones, the possible ones, the ones that are still true. Then, see, we even did it here. P possibilities. Oh, I was about to rewrite this. For such possibilities, and this pattern check. Such that is not enabled pattern check direction. First element of such P impossibilities, that's the pattern index. Okay, and then we get just the unique ones. So is not enabled. Okay. Yeah, we even look in the adjacency rules. Put that adjacency key. If we don't find it, we have invalid rules. Otherwise, we return the inverse of V. I don't think this is quite what we're looking for. I think this is not quite right. Because remember, we just said a few minutes ago that we want to eliminate the values where this target pattern appears as pattern B. We're not necessarily looking at whether it's allowed by the adjacency rules or not. It's if it is allowed by the adjacency rules. Yeah. If it is allowed by the adjacency rules, like this adjacency key is allowed, then we want to filter that. This might almost work actually with if we not enabled call anywhere else for anything. I don't think so. Okay, so I think we can make this work if we take out this here. This is the offending part. Alright, so this filter will only enable it out of it if it's enabled. So it should be like such that this rule is enabled. Get rid of the not part. And just return B. All right, pattern check. Oh, okay, pattern XBs. Okay, so pattern check is a value from the input patterns. For each of the input patterns, pattern to check. Why would it be a non-empty pattern index? I think this doesn't make sense. All this pattern check up here. Get rid of this. Yeah. So this case here for is enabled. We don't want error. We just want false. Is enabled is just a filter here. So if the pattern's not even enabled, don't even worry about it. Or the possibility is not even enabled, don't worry about it. We only care about the ones that we can. The possibilities that are actually real here. Okay. Yeah. Okay. I think that might possibly, potentially, kind of, sort of work, maybe. All right. Pass at the pattern index, the direction, the adjacency rules in the cell. This back to pattern indices. And then we just have to convert those into our remove patterns. And then we're good. Map a function over that. Pattern index, that's the pattern to check. Direction. That'll be our pattern X. Our direction. Cell. We still, sorry, have a parameter to give it. That's what I was thinking. The adjacency rules for the cell, right? Okay, then our map becomes pattern index, a list of remove patterns. That's not quite what I was expecting. Hang on. How come? Da-da-da-da-da. Not enabled. Should be returning a list of pattern indices. That's right. If we map over the pattern indices. Right. Oh, we need a pure. There we go. Pattern index to a remove pattern. Cool. Might actually need to bind the direction, this cell index here. Cool, cool. And then just removal pattern. The pattern index is first. And then the cell index is a second argument. So then we will have to flip. Remove pattern, and we'll pass in the cell X. Okay, flip the arguments of the constructor, pass in the first argument to it. Okay, and then it receives the second argument from the map. And then, so then we just have to implement from direction. Should be pretty straightforward, hopefully. Let's just add it down to the helpers at the bottom. Alright, it's going to take our int, our direction, and return an int. And we can just land a case on that direction. So we have up, right, there we go, down, and left. Right, super. So in the case of up, we want to be able to wrap around the from direction has to be like toroidal, I guess, around the grid axis boundaries. We know what the grid boundaries are. We don't need to support arbitrary, or do we need to support arbitrary grids? I think we might. So it was basically, what are we going to mod by so that it wraps around, basically, and then we go in the up direction, for example. So I think what that means is we need the grid size. Let's go to the wave state. We got our grid. And I got the bounds of the grid, which tell me to give me the information I need to know how to mod around it. Okay. Maybe we pass that in there. Then I think we're gonna need that in every case. I think maybe I'm gonna get rid of the lambda case here. Find out that grid bounds. Good width and height. You might want to function over that. So I think, if I remember correctly, the array bounds are inclusive. Oh, right. It's gonna be I0, I0. For some reason, GHC is having trouble figuring out what the type of grid height should be. It's figured out that they're the same type. Okay, let's see if I've done similar things. Have here. Okay. Well, if we type apply it as integer, we're saying it's integer. So that's fine. Okay, so then this function here, by map. And we want, is there like a decrement? Google. So the way of writing this would be okay, we're just having type mismatch issues here because yeah. Right. It's not saying these are numeric. XA is orderable. Let's try again, yeah. I'm gonna grill slapped on there. Okay, that's all we need. Let's just pull those out the way they are. Okay. We'll case match here on direction. Left. Booyah. Just like that. Okay, so in the case of up, we want to subtract 1 from our input x, xy. So we'll subtract 1 from y, modulo our, or if it's less than or equals 0, if it's less than 0, when we subtract 1 from it, we should give it the grid height minus 1. X should be untouched. So we'll call let prime be y minus 1. X untouched, and if y prime is less than 0, then we want grid height minus 1. else y prime. Alright, doesn't have to be beautiful. It's all good. Okay, right prime. This is going to be changing x. And we're going to be adding 1 to it. And then in this case, if x prime greater, actually it could be greater than or equal to root width. In that case, 0. Oh, we don't even need a mod. Whatever. Anyways, otherwise it's x prime. Then y isn't changed. Down, we're changing y again. This time we're adding 1 to it. So they checks range of y prime greater than or equal to grid height. And 0. Else y prime. And x again. Width -1. Oh, and y is unchanged. Yeah. Probably could do something with the mod there. Whatever. We're good. Let's move on. We've got from direction, base select. This needs the grid. Base state grid. And that removes all of that. And then we've got this little funky one here. Oh, right. What did I call it? Good. Get cells. Okay, sorry. Right. Okay. So that's okay. So grid width, grid height aren't exactly the grid width, the grid height here. They're the bounds. They're gonna be like 0, 0 to bop, bop, bop. So we really want to map the second value of each of those. Array into cells. Am I not right in thinking that biomap is what I want? Oh, okay, yeah. All right, I'm going to type a biomap wrong. Biomap takes the two functions, one for the left and one for the right. Day 2. Oh, weird. Okay, cool. All right. Tuples are funny things. Okay, cool. That one's better. Oh, we had some tests for not enabled. Oh, smart. Smart past me. Let's go fix those. Okay. Let's look at the spec for this. Okay, so our context here, this is our adjacency map. All right, 0 and 1 up through. That means this. That means this is allowed. 0 is allowed to be up from 1. Might want to change the order of the arguments just to make that easier to read. Think about it. All right, 0 is allowed to be down from 1. That's false. And 0 is allowed to be left of 1. That's false. And 0 is allowed to be right of 1. That's false. That's how we read those. Okay? So we're given a cell with 2 possibilities. 1 possible. Alright, so we have 2 possibilities here, 0 or 1. 0 is possible. 1 is not. Okay. Hey, Happy Peach, and welcome, Raiders. What's up? Welcome. Yeah. I'm just getting my code to compile again. Nice to see a Happy Peach. Yo-ho. Oh, sick. I love how they're Haskell streamers. Who was it? I will give them a follow and a like. Awesome. Followed. That's sick. More Haskell streamers, more love. Let's do it. Called a student. Cool. Took Haskell for your intro class. It was tough. It is. 2 years later, you're liking it, and you're back. That's awesome. I'm so happy for you. You know what? It's hard for everybody. Like, when I started Haskell, I was like 20 years into my career. Yeah, about thereabouts. And it was so hard. But yeah, like 5 years later, I'm still at it. I do work at Haskell day to day in my day job. Quite fortunate in that regard. Yeah, it was like a goal of mine for a while there. I wanted some production experience with it because I had like a lot of theories about, you know, it would be awesome to write software in Haskell, and I'm sure it'd be great to use in production systems and all these ideas about it, but never got the chance to test them out. So I'm glad I found a place to work where I could do that. And it's been pretty great, I would say. Yeah, so if you want anything you want to know, feel free to ask questions. All good. That's pretty alright too. I was a Python programmer for a very long time. A good 10 years or so. Okay, so my spec here has changed because I changed the definition of the not enabled function. Oh, cool, no way. Yeah, I'm in fintech as well. Okay. I do. That I do. So you know about Mercury, that's pretty awesome. Oh, no way. I might have met them, who knows. Small world. Maybe. Sounds familiar. But briefly. I don't think he worked on my team, though. Yeah, sounds familiar. Well, that's so cool. A lot of our interns tend to come back and work for us. Like a good number of them. Okay, so let's see my first case here. Oh, good. Well, we're hiring quite a lot, so tell him to keep his eyes peeled on our jobs page. So to remove, not enabled. This just needs to be. So if we give it 1 down. Oh, no worries. No, I'm fine with distractions. So if you have any questions about the code or anything, that's fine too. Backseat programming, all welcome. Okay. So yeah, I changed the spec here of to remove when I changed the code, but I didn't change the spec first, so now my tests are like, meh. So not enabled here is supposed to be checking if I give you a pattern in a direction. The pattern I'm giving you is the one I've eliminated from a cell. The direction is the direction that cell that I've eliminated, done the elimination from. And what I'm asking not enabled is, does this cell, right, the neighbor of this cell, let me draw this out. Does the neighbor of this cell have any rules that would not be possible? Like, can I by choosing this eliminated pattern, I'm looking for possibilities in this current cell that are no longer possible given the adjacency list. So what I mean is, I've got my handy dandy illustrative tic-tac-toe board deluxe, right? This cell here is the one I've eliminated from. I've eliminated pink, let's say. Right. So now I'm going to each of the neighboring directions, say up here. Right. I'm saying, okay, in this cell, you have a list of possible values you can still have, and there's an adjacency rule that says, like, what is allowed, what values can you place in this blue cell here where they're allowed to be above pink, or pink is allowed to be down from. Right? And so I want to eliminate, if I'm eliminating pink, then I want to go through the adjacency keys here. And I want to pick out rules where they would be true for the direction, where pink would be the target. And then we want to select this cat here, this pattern index over here. And then that means that we can't possibly choose this one, right? If pink is no longer available in the neighboring cell. And so we want to eliminate that as well. We want to get rid of it. And put it on our elimination stack. Okay. Okay. So this test should say, given this adjacency list, right? We have, this says 0 is allowed to be up from 1. So in the direction up. Okay. And it's true. That's a loud rule. This one says 0 is not allowed, 0 is down from 1, that's false. If 0 is left of 1, that's false. So any other case is not allowed. Right, so 0 is only allowed to be up for 1. So if I want to remove to return 0, it means I want to give in 1. I want to give up. And these aren't compiling anymore at all because we changed the type signature here. So we'll get those fixed in a second. Hopefully. So keep removing enabled possibilities. So here, should keep enabled possibilities. So 1 be allowed to be down. Ooh, no. I think that'll be true as well. And given a cell with 2 possibilities, all possible. Okay, so in this one, 0 and 1 are both still possible values we could pick for the cell. And if we remove, if we call not enabled with 1 on down, right, 3, these are the possibilities. Okay, yeah, so we're not enabled, we're passing in 1. Is 1 allowed to be down in this current cell? So 1 is the one we're trying to eliminate from your neighbor. Alright, so for 1 appears here, we're looking at all of these. And these. The other ones don't matter. 1 down here. That one's false. That one's false. But 1 up is false. And 0 1 up is true. So 0 would be the one. not enabled in this case. So I don't think this test makes a whole lot of sense at this point. I think that would be 0. Might not make sense. Let's just get to compile. Not enabled. 1. Up full cells. This one's the same. Well, that's up, so maybe nothing. Maybe there might be a red one in here. 2 failures. Yeah. Okay. Okay, I said expected 0, it says nothing. Right. 1 down. 1 down, false. 1 down, false. Yeah, that would be nothing. Now let's look at the implementation of this just quickly to fill some of y'all in. So usually I tend to want to write my tests first because I write them as like specifications like this. And I made a boo-boo because it's been a while since I've worked on this project. I've been off sick for a few weeks. So I'm rediscovering all the things I wrote a while ago. And let's see, the not enabled. Yeah, I'm gonna get rid of that comment. All right. So the goal of the not enabled thing was like what I showed you in the picture there. All right. I give you a pattern to check, a direction, the adjacency rules, and the current cell that we want to get any rules out of there that would not be enabled. That means we want to get the patterns indices in the adjacency rule set, where if we picked one of those out of the possibilities, it would not be legal anymore, that kind of thing. Happy Beach. What is the scope of the project? So wave function collapse is a, let's just look it up. It's I would say it's an algorithm that belongs to constraint solving. It basically takes an input picture, a small input picture with like some patterns. We analyze that, a small input picture, and we generate a larger picture from it. The larger picture is going to have a lot of self-similar features that come from the smaller picture, as in some of these examples here. You take this tiny little picture over here, and then you can generate all these other kind of output images that look something like this, of local similarity. Right, or this little picture here, yeah, you can generate all kinds of things like that. Yeah, so this is often used in game development for procedural generation maps or textures and things like that. So I'm learning about the algorithm, learning how to implement it in Haskell, that sort of stuff. Okie dokie. Yeah, we might make a game with this. We've made games in the past in Haskell on the stream. And yeah, we might make a game with them. It was more, this project, I do lots of different projects on here. Mainly because a long time ago when I first started the stream, there was a lot of people out there who would say things like, you can't make real software in Haskell. It's a research language for academics, that sort of thing. So I thought that was a little bit ridiculous, and I wanted to show that even a smooth brain like me can use Haskell and get things done and build real software with it. So I tend to pick kind of smallish project, but not trivial projects, and build them in Haskell to kind of, you know, get some practice, get some experience, have some fun. So not all of them are games, but some of them are games. This one's just a library just to see if we can implement this kind of non-trivial algorithm and learn about it. Because it's one of those algorithms that, like, I've known about for many, many years. I've tried implementation before and never really got all the way through. So I wanted to learn it really and build an implementation for it. Okay. So we're going to try and see how far we can get here. So I've got maybe about 15-ish minutes left in the stream. Okay, so we got one more failure thing. This one says 0 should be eliminated in this case. Why should 0 be eliminated? Well, I think the way not enabled, I've changed not enabled to work, is the pattern index here and the direction. We're looking in the map. The pattern B here is our input pattern from the possibilities. No, from the function. Pattern to check against. Okay, so the pattern B is like the target pattern that you can overlap. And so we want to return the pattern A index if pattern B shows up here for the direction, and that V is true. That is the overlap is allowed in the adjacency rules. And that's what the is enabled function says. And so that possibility is no longer possible. So we return that pattern index, and then we just make sure that the list is unique. Because the adjacency rule map can mention the same pattern multiple times. All right, and so as we do these removals, we're going to put them on a stack of removals to do, and then keep going. And that's how we're going to propagate out the eliminations. So this one says one up. And the one thing I'm looking at with this spec now that I'm starting to realize I'm kind of a little bit of a dum-dum about, I think, is that the cell we're interrogating here that we pass in, this cell here, right? This cell here, when we use not enabled and get neighbor removals, this is the cell we want to look for patterns that we can remove from. The direction, I think, is the problem. We get the neighbor removals here. The direction is for each of the directions from the cell we're currently eliminating from. So like we're eliminating that pink one in the middle, and we're going to all the neighbors, and we're saying, hey, do you have any rules, like any pattern indices I can remove that you get from your possibilities list? Right, and so the direction here, or the cell, we get the neighbor removals. Yeah, I'm doing something funky with that here. It's not right. I think what's funky about the code here is that the cell we want to eliminate from, peep, 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 peep. Right, we chose pink here. We're good. So we're eliminating this. And we want to say in get neighbor removals, get me all of the pattern indices in the adjacency rule set that you have. So this cell is relative, right, up from this eliminating one. Yeah, okay, actually, no, I'm not doing anything funky. No, this is right. This is right. This is right. Yeah. Right, so the adjacency key, when I was telling you how that was read, bang, 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 here. We read this as pattern A. That would be the pattern on the left of the rule here. Is allowed to overlap with pattern B in direction. So in our arc drawing up here, right, pattern A could be like blue or yellow, is allowed to overlap with pink in the up direction. And if that's true, then when we eliminate pink, we can no longer legally place yellow as a possibility up here. All right. So I think this makes sense. And so that's what we want to kind of queue up for elimination. So that when the propagate step then goes back, checks the stack of removals to do, and sees, oh, there's another one to remove, and it goes down and does the removal for that cell, and so on and so forth, until the stack is empty. Savvy? Hopefully, hopefully. So in which case, I think actually these tests are good. So we're saying in not enabled, for pattern index 1, that's in the target, in the direction up, in this cell, given these rules, do you have anything you can remove? That is, like, any rules that are not enabled. The pattern indices that are not enabled by the adjacency rules anymore. And if we go, well, it's 1 in any of the B positions. All right, we see that 1 in a B position with up is true. That would be allowed, but we can no longer place 0 as a candidate there, so 0 would be returned. The only other case we have 1 and up, right, it's false, so 1 wouldn't be returned here. We have no other 1-ups. 1-ups. That's good. So I think the wording of it might be just the part of the spec that needs to be changed. We're given a cell with 2 possibilities, all possible. It should return not enabled possible abilities. And this one is more saying should not Return possibilities that are not enabled. Alright, so if we look for one down. Alright. This isn't even enabled. It's not even possible, so it should return 0. And one down, also not enabled. That's kind of confusing, though, with the double negative. Should return... that are no longer enabled. Do not consider rules that aren't allowed. Okay. Okay, cool. This is maybe a good place to make a commit. Okay, implement from direction to get the cell that we want to pull out of the grid. We implemented eliminate and get neighbor removals. We added push removals, which is going to push the removal patterns to the stack. In the wave state, we haven't implemented it yet. We updated the implementation of not enabled to better suit our usage here. Now, I wanted to double check. So the from direction takes a grid, a base cell. So that's this. This is the target cell that we're doing the elimination function. Right, we're modifying the cell by removing the cell index from that removal and get the neighbor removals. So we get the neighbor removals with direction for each direction. Okay. So this is the propagated cell pattern index. This is the one we're removing from. Right, the target that we're removing from. Right. So this each of those directions. So when we go to remove the cell, we got to get out. Yeah, we use remove cell index. We use this from direction function for that direction we're given from the one that we're eliminating from. And if we say up, that's going up in the Y direction. The target, yeah, okay, that makes sense. That still makes sense, yeah, okay. Good, okay. And tests, I'll also say we're right about this, sort of. They're probably not the most specific tests, but they're okay. Let's commit that, stage, team, beep. I'll say this is adding, add eliminate, and neighbor removals. Cool. And that's about all the time we got for today. So we got it back to compiling before the end of the stream. Awesome. A little bit of progress. I like it. Okay, so thanks Raiders and everybody else for tuning in. If this is your first time, welcome. I'm Agent Ultra. You can find me on Mastodon on the TypeStop.pl server at Agent Ultra. My profile's got all my links to my site. My YouTube channel where I back up my VODs. And Twitch, I'll just post that in chat. It has been an absolute pleasure coding for you and hanging out and chatting. And of course, I do these streams once a week, usually on Tuesday evenings at about 10 after 8 in the Eastern Standard Time Zone, or the Eastern Time Zone. So if you want to write that down and just show up, or if you're on Twitch, you want to subscribe and do all that stuff and follow and whatever, that's much appreciated. And then you'll get, if you turn on your notifications, you get notified when I do streams. And of course, if you go to my YouTube and you're watching in a different time zone, you know what to like and subscribe and thumbs up and all that stuff there. And the code for tonight's project, and the project we've been working on for a little while, is on GitHub. It is at Agent Ultra. I'm Agent Ultra there as well. Wave function collapse. All right, so you can check it out there as well, and pick it apart. Also, go to the link above my head. If you feel like chatting between streams, there's a cool website called declarative.tv, and there's a link on that website to a Discord server. Welcome, Justinian. Thanks for watching and chatting with us. And if you go to the Discord server, there's a channel there for this stream, so we can chat between streams. Show me your projects, show me your code, ask your questions, whatever. It's all good. There's also a lot of cool other streamers there you can meet and follow along when they go live as well. So it's a very cool little Discord server. Not super active these days, but can always use more love. And that's all wrap. So thanks again for watching, and I'll see you next time. May your monads be free and your types always check. Take care out there and happy hacking. Stream over. If I can find my button. There we go.